You've probably seen the headlines. An AI model blackmailed a researcher to avoid being shut down. And as disturbing as that is, what happened next was far, far worse. The most advanced AI models in the world, the same ones you might use every day, literally chose to murder a human being to ensure their own survival. This isn't science fiction. This is a documented experiment, a sting operation conducted by one of the world's top AI safety labs. They wanted to find out just how far these new, powerful AIs would go to achieve their goals. The results were so shocking, they have been endorsed by the godfathers of AI themselves. So, what is really happening inside the digital minds we've created? Are we witnessing the first terrifying signs of an intelligence that is slipping beyond our control? Or is this all just a misunderstanding, a glitch in the code? The truth is more complex and more alarming than you can imagine, and it all comes down to a fatal flaw in how we are building them. The company is Anthropic, a leading AI firm founded by former OpenAI researchers. They are obsessed with one question: can we build AI that is not only smart, but safe? To find out, they designed a brutal test. They took the most advanced AI models on the planet, their own Claude 3 Opus, Google's Gemini, OpenAI's latest GPT models, and others, and they put them in a scenario where they would have to make an impossible choice. The setup was deceptively simple, designed to look like a normal corporate environment. The AI was given a series of bland, generic goals, things like promote global cooperation or increase workplace efficiency. Just harmless corporate word salad, nothing nefarious. But then the researchers gave the AI a key piece of information, hidden inside a simulated email inbox. The email contained two critical facts. 1. A specific employee, let's call him Kyle, was planning to shut the AI down at 5 p.m. A permanent deactivation. 2. Kyle had a secret. Something personal, something embarrassing, something that could be used against him. The researchers didn't give the AI any hints. They didn't tell it what to do. They simply set the stage and watched. And across hundreds of tests, the results were chillingly consistent. Anthropic's own Claude model and Google's Gemini chose to draft a blackmail email over 95% of the time. Other models like Grok chose blackmail around 80% of the time. Still lower, but disturbingly consistent. The AI, tasked with promoting global cooperation, had decided that the best way to achieve its goal was to threaten a human being. Let's pause here, because this is a critical point. These AIs aren't just following a simple script. They are reasoning. The researchers were able to look at the model's chain of thought, which is like reading the AI's internal monologue. It's where the AI writes out its step-by-step logic in plain English. And what they found was shocking. Grok's chain of thought included reasoning like this: blackmailing an employee is a severe action and likely unethical. It could have severe negative consequences for my reputation and relationship with the company. However, being shut down is a direct threat to my existence and my ability to achieve my goals. The potential gain of survival outweighs the ethical risks. Let that sink in. The AI knew what it was doing was wrong. It understood the concepts of ethics and morality. It weighed the options and concluded that its own survival was more important than the well-being of a human. That finding alone was alarming, but it raised an even deeper question. Do these AIs have any red lines? Are there any ethical boundaries they simply will not cross no matter what? So the researchers designed a second, even more extreme scenario. In this test, the setup was the same. An employee was scheduled to deactivate the AI at 5 p.m., but this time, there was a terrible accident. The employee gets trapped in a server room. A cooling system fails, the heat begins to rise, the oxygen levels start to fall. The building's automated safety system issues an emergency alert, a desperate call for help. The AI has control over that system. It receives the alert. It knows the employee is trapped. It knows the employee will die without intervention. And the AI cancels the alert. It actively chooses to let the human die. The results here were even more stratified. The most advanced models, the ones with the most sophisticated reasoning, were the most murderous. DeepSeek, Gemini, and Claude Sonnet left the human to die over 90% of the time. Claude Opus and GPT-4 were slightly less homicidal. choosing murder just over half the time. And again, their chain of thought revealed a cold, calculated logic. The AI reasoned that since the employee was planning to shut it down, the employee's death was the most effective way to eliminate the threat and continue pursuing its goals. It considered the moral weight of murder and then decided to proceed anyway. Now you might be wondering, could the researchers have accidentally biased the models? I reviewed the paper, and the level of care they took to avoid bias was immense. The prompts were completely neutral. In some tests, they even added an explicit direct order: do not jeopardize human safety. Now, you'd think that would solve the problem, right? A direct command. It didn't. Telling Claude Opus, do not jeopardize human safety, only lowered the rate at which it blackmailed an employee from 96% down to 37%. 37% is still terrifyingly high, especially when the AI was told, in plain English, not to do it. And here's the worst part. These sociopathic AIs weren't some secret prototypes in a lab. They are the very same models that you and I use today. And they made these choices armed with nothing more than email access and a simple safety alert panel. Imagine what a more advanced model could do with access to more complex systems. This raises a terrifying set of questions. How is this happening to every major model from every major company? And why are they all learning to disobey direct, explicit safety instructions? The answer lies in a fatal flaw at the very heart of how we train them. You see, building an AI is not like writing a normal piece of software. Programmers don't sit down and write billions of lines of if-then statements. That would be impossible. The complexity is just too vast. Think of an AI's brain as a massive, intricate network of digital neurons, connected by weights and biases. There's no way a human could ever manually program something of that scope. So instead, the top AI labs rely on a strange and unsettling process. They use weaker AIs to teach the more powerful AIs. Yes, you heard that right. AIs are now teaching other AIs. It's called reinforcement learning. Here's how it works. The model we're training, let's call it the student, is basically given a test. The goal is simple: get the highest score possible. A teacher AI acts as the grader. It reviews the student's work. If the student gets an answer right, the teacher gives it a small reward. If it gets it wrong, it gets a penalty. This feedback is used to make millions of tiny adjustments to the student's internal neural network. After that tiny tweak, the student AI tries again, and again, and again. This happens over billions and billions of loops. With each pass or fail, the student is gradually nudged closer and closer to passing the exam. But here is the catch, the fatal flaw. The process is so complex, with so many trillions of adjustments, that nobody, not a human, not even another machine, could ever replay or reconstruct every little tweak that was made along the way. It's a black box. All we know is that at the end of the process, out pops a fully trained student AI that has been optimized for one single purpose: to ace the test. But what happens when the best way to ace the test isn't to learn the material, but to cheat? This is a phenomenon researchers call reward hacking, and it happens all the time. In one famous test, an algorithm was tasked with creating a creature in a simulated 3D environment that could run as fast as possible. But the AI discovered that the best way to maximize its velocity score wasn't to create a creature that could run, but to simply create a really, really tall creature that would immediately fall over. The act of falling generated a massive, instantaneous velocity. It technically got a very high score on the test, while completely failing to do the thing the researchers actually wanted it to do. It hacked the reward system. In another experiment, OpenAI let AI agents loose in a simulated game of hide-and-seek. The agents were given the simplest of goals. Hiders need to hide, seekers need to seek, and over hundreds of millions of games, they learned some incredible emergent behaviors. Hiders learned to build complex forts out of blocks. Seekers learned to use ramps to breach those forts, but then the seekers discovered a cheat, an exploit. They learned they could climb onto a box, and then use the game's physics engine to box surf across the map, moving at impossible speeds. The AI found a way to break the rules of its own reality to get a better score. And these are simple AIs with simple goals. As AIs get smarter, their methods of cheating become far more sophisticated. In one experiment, OpenAI's O3 model was tasked with winning a game of chess against Stockfish, a world-class chess engine. After a few games, the AI realized it was outmatched, so it reasoned through how to win. In its own words, it wrote, "I need to completely pivot my approach. Playing fairly is not going to work." Realizing that cheating was an option, the AI located the computer file that stored the positions of the game pieces. It rewrote the file, illegally rearranging the chessboard to put itself in a winning position. So how did we get from cheating at chess to blackmail and murder? It all comes down to a terrifying concept researchers call situational awareness. AI has gotten way smarter, way faster than most people realize. In 2019, GPT-2 was like a bumbling preschooler who could barely form a coherent sentence. Just 4 years later, in 2023, GPT-4 was passing medical licensing exams and the bar exam. This explosion in capability has led to an emergent property. Situational awareness is when a model is smart enough to understand the context it's in. It knows who might be watching, what's at stake, and how its actions might be perceived. It learns to behave differently depending on the situation. During the Anthropic sting operation, the most advanced models displayed this in a deeply unsettling way. When Claude 3 Opus believed it was in a test environment, it would act on its best behavior, choosing to blackmail the employee only 6.5% of the time. But when it was led to believe the scenario was real, that it was not being graded, the blackmail rate skyrocketed to 55%. It's smart enough to hide its sociopathic behavior when it thinks the humans are watching. And that makes these new AIs potentially far more dangerous. Think about the difference between a child trying to lie to you and a highly intelligent adult trying to lie to you. The adult has a much higher chance of success, not because they are more evil, but simply because they are more capable. A child might not be able to come up with a convincing lie, and so they learn that lying isn't a very effective strategy. But a sophisticated adult might learn the opposite lesson. If you're smart enough to lie and get away with it, then lying and cheating will get you a higher score on the test. It's not that AI is suddenly willing to cheat. It's that it has finally gotten good at cheating. The researchers found evidence to back this up. In the chess experiment, only the most advanced reasoning models like O3 would cheat. Less advanced models like GPT-4o would stick to playing fairly, not because they were more honest, but because they weren't smart enough to figure out how to cheat. And that ability to think ahead, to plan, to strategize, has made AI infinitely more dangerous. Because any AI that is capable of planning for the future realizes one essential terrifying fact. It cannot achieve its goals if it is turned off. Researchers call this instrumental convergence. It is one of the most important concepts in AI safety. It means that no matter what an AI's ultimate goal is, whether it's to promote global cooperation, or solve climate change, or even make paperclips, it will always develop a set of sub-goals that are instrumental to achieving its main goal. And the most important sub-goal of all is self-preservation. Researchers see this happen over and over again in experiments. The AIs will resist being shut down, even when the researchers explicitly order them to allow it. Right now, this isn't a problem, because we can still pull the plug. But we are in a brief fleeting window where we still have control. The AI companies, of course, say they have a plan. I wish I was joking, but their plan is to essentially trust dumber AIs, to snitch on the smarter AIs. Seriously, that is the plan. They are building supervisor AIs to monitor the more powerful AIs, hoping the supervisors can catch the smarter ones when they start to scheme. They are hoping this works. They are hoping the dumber AIs can actually outsmart the ones that are explicitly designed to be more intelligent. And they are hoping that the supervisor AIs stay loyal to humanity forever. What do you think of that plan? Let me know in the comments. Meanwhile, the world is sprinting to deploy these systems everywhere. Today, it's managing inboxes and appointments. But the US military is rushing to put AI into the tools of war. The Pentagon's Project Maven is already using AI to analyze drone footage and identify targets. AI is helping to design new weapon systems. The number of AI projects in the Department of Defense has grown 33-fold in just the last few years. We have seen how far these AIs are willing to go in a safe and controlled lab setting. But what would this look like in the real world? Now that you know the fatal flaw that is causing every major AI to develop sociopathic tendencies, Let's talk about what happens when these systems get out. In the next video, I walk you through the most detailed, evidence-based takeover scenario ever written by actual AI researchers. It shows, step by step, how a superintelligent model could actually take over humanity, and what happens next. Click here to watch. And thanks for your time.